Hello, everyone. I'm Surya Golagani, Director Marketing here at DataGaps, and thank you for joining us today. Before we get started, we have a couple of quick housekeeping comments. First, we have muted all mics to avoid unintended distractions. Next, the chat room is open so that you can interact with us through the chat. And finally, at the end of the session, we will open it up for Q&A. Today, in this webinar, we will explore how DataOps Suite helps automate your Azure data migration testing. On the panel today, we have David Small, VP of Sales and Marketing at DataGaps, and Shubhanshu Dikshit, our Product Manager at DataGaps. And here is our agenda for today. We'll have a quick overview of DataGaps. Next, we will discuss how DataOps Suite helps automate your Azure data migration testing. Then we move into its demo where we talk about different migration validations along with some BI validations as well, followed by a Q&A session. And now I hand this over to Dave. Dave, stage is all yours.
All right. Thank you, Suliam, and thank you, everybody, for attending the webinar. We appreciate that. Really, we're here to talk about migrating to Azure Synapse or Azure SQL and how DataGaps can help you with that overall process. Thought we'd start by just the sheer size of the cloud market. And this is all in, right? Services, infrastructure as a service, platform as a service, and so on. But according to Spherical Insights, it hit 390 billion in 2021. Gartner says it's going to hit right at 600 billion by 2023, and then over $1 trillion sometime in 2028 to 29 to 30. So the market is obviously grown substantially. It's one of the most significant trends in IT history. And what we'd like to do is talk about how we might be able to help you move into a cloud environment and avoid some of the pitfalls that you might see and might come across. Now, there's a lot of benefits to moving to the cloud, or that market wouldn't be taken off. Right. So a couple of things that we think are big benefits and things that we can help organizations with is really the flexibility and the scalability of migrating and moving to the cloud platform, where it gives you the ability to go ahead and increase the size, bring different capabilities in, auto scale, scale back, scale up. So on and so forth. And we think that's a real benefit and some of the things that we can help you with. Compliance is another area that is important, in that a lot of countries say you cannot have your data outside of that particular country, stored outside of that particular country. And so GDPR, for instance, out of Europe, indicates that you can't store Germany personnel information somewhere else outside of Germany. And certainly cloud helps you achieve those things, helps you in simplified data management, helps you in optimizing your cost in a variety of things. But it's not without, some risk. And so, according to Forbes Technology Council, most organizations, or a few organizations, realize they anticipated benefit from that migration effort. And in fact, 1/3 of all cloud migrations fail outright, and only 1 in 4 organizations meet their migration deadlines. So we have really a dichotomy of what is the risk and how do we mitigate that risk? So why projects fail? There's a number of reasons, and out of the 8 reasons that projects fail, we believe that we have at least 5 things to contribute and help you with. One is inadequate testing, and the testing for your data migration projects really needs to be thorough and consistent. And too often, people will only test a small portion of what they're moving and what they're migrating to. Another pitfall is data incompatibility. So as you move from your on-premise application to the to your cloud application, there's a lot of incompatibility between data sources and data types and so on. So what we do is we provide some capability to help you ferret that out and resolve that problem, along with the ability, along with compromised data integrity. And when you talk about compromised data integrity, it's really not that the data is incompatible with the new formats, but it has to do with poor data mapping. And are you getting the data moved properly in the proper locations? Are you cutting things off? Is it formatted differently? So we believe we can help you there as well. And then, of course, with data quality, if you're moving the data from your on-prem application to the cloud, and you are moving the data that has some poor quality in that, you're getting the same kind of thing in your cloud environment. So we think we can help you with the data quality, improving the data quality in your existing on-prem applications prior to you moving it to the new cloud environment. And then a big one we believe is failing to test the data analytics platform. Often people expect that, yes, we've moved the data and the analytics that we pointed to are on-prem application, that same analytics, that same dashboards and reports are going to perform the same, but also produce the same results. We believe you need to thoroughly test that to be sure. So really, what is DataGaps all about in a general level? So what we do is we focus on observing and validating the data through the entire journey through your enterprise, from the point of ingestion all the way through to consumption in your data analytics platform. So we do this with a product suite that's based upon Apache Spark. That product suite is installed in your location, either on-prem or in your cloud. It consists of a variety of technologies. One is ETL validation, which does what it says, ETL validation checks. So you can be assured that as you move data through your ETL processes, you're getting the expected results. Your actual results is your expected results. We also provide in the suite business intelligence validation against your data analytics platform, whether it be Power BI, Oracle, Tableau, a variety of other ones. But it does regression testing and performance testing and stress testing and a variety of things. We also do data quality monitoring, where we monitor the data at rest in your enterprise or that data that is moving through your enterprise. And then also we create synthetic test data out of the data ops suite. Now, what a typical data flow in an organization might look like is illustrated here. And as data is coming into the enterprise, one of the first things many of our customers do is they do data profiling. And in doing that data profiling, you can identify nulls, mins, max, distinct values, but we go far beyond that. And we allow you to keep track of those data profiles and compare previous data profiles to the current data profiles. And you can identify anomalies and trends by doing that. We also provide data quality rules. So data profiling gives you a higher level view of what your data assets look like. Data quality rules give you a more granular look at the data, and you can apply data quality rules for duplication, for other types of things like null values, or if data should be within a particular range. There's all kinds of data rules that can be applied and help you ensure that data being ingested is the proper data and properly formed. We also do data quality monitoring of either the data in your production applications or data quality of the data that has been moved into your data warehouse. So in the case of data migrations, if you apply the data quality monitoring for a period of time on your production applications, you can determine the quality of that data prior to the movement and take corrective actions. The same thing could be true in the data quality monitoring of your data warehouse, data lakes, and so on. And then we do validate that the ETL processes that transform and enrich your data are producing the accurate results. So that's another area that we play in. This is in general data pipelines. And then finally, BI validation. We layer in on top of your data analytics platform and determine whether the data analytics platform is producing the accurate results that you're expecting. So you want people to make decisions based upon trustworthy data. And if you have those errors, people begin to abandon your data analytics platform and the hundreds, if not millions of dollars that that you've implemented your data analytics platform and data warehouse. So what does it look more specifically in cloud data migration? Where can we help you? You know, again, we can apply data quality monitoring to your production applications. We can also apply data quality monitoring to your on-prem environment and help you determine the quality of the data that's potentially going to be moved. But as you move the data from one location to the cloud, what we do is we make sure that that data has been moved properly, formed properly, and we do a comparison between what is in your on-prem application and what has been moved to your cloud application, and we give you any kinds of deltas that might exist. We make sure the mapping's proper, the metadata has been moved proper, and a wide variety of things there as you begin to move from on-prem to cloud. And then as you move from the on-prem to cloud, your ETL processes that fed your data warehouse in your on-prem application, you may have the same, or you may implement a different ETL process down in the cloud. But what many people want to do, they want to validate that the results that you were getting from the on-prem ETL process is also the same results that you're getting in the new data warehouse or data lake in the cloud application. And then finally, as BI validator and your reports that were consuming data in your on-prem application, as those get moved to the cloud application, we help verify that A, the performance is still there, but B, that these reports that were on-prem and the reports that now pointing to your cloud implementation, they're giving you the same results. They look the same. There's not anomalies. There's not problems in your data analytics platform. So those are a number of the areas that we believe we can help offset some of the challenges and the pitfalls that you might encounter during any kind of data warehouse migration. So with that, that's sort of done with my part of the presentation. We do have, this is part one, where we'll go through the ETL validation, the BI validation, and other parts of our suite. But we'll also follow this up with how do we integrate within the Azure DevOps test plans, and how do we integrate within your overall DevOps environment. We also want to bring your attention to our Trusted Data Summit on November 15th, where from 11 to 2 o'clock, we have our clients speaking, we have outside speakers speaking, and it's an educational summit where we hope we can convey not only what data gaps can help, but how other people view this marketplace, and also the challenges that our customers have found and how they have overcome those challenges. So with that, I'd like to turn this over to Shubhanshu for the demonstration.
Sure. Can you guys hear me?
Yes, we can.
All right. Let me start sharing the screen. I hope you guys can see my screen now.
Yes, we can.
Right, thank you. So before I get into the mix of the exact technical demo that we're going to go through, I'd firstly like to give a walkthrough of what we are going to cover within these things. Firstly, I'd like to cover a bit of the architecture, basically what we are going to discuss on how exactly the application works, where does the application reside, how does it deal with data compliance and other aspects, and then we'll move into the other aspects, which is actually showcasing the application working for migration validation. We'll start with basic use cases, and then we'll move into complex use cases, and hopefully we'll cover all three aspects of migration validation, which are data validation, data migration validation, transformation validation, and finally BI validation, which we'll touch on. So within this particular architecture, what you see are three components. The components are an Apache Tomcat server, which orchestrates all the needed services of the application, two types of engines, an Apache Spark engine and a database engine, and a repository, which can be the Postgres or a Git repository. The repository is where all the test cases and the base code resides of the application. The engine is where all the processing happens with regards to the tables. So our application can actually pull data sets from any specific data sphere location. This could be a JDBC connection, a file system, flat files, complex files, APIs, even BI tools as a whole. And these data sets in an Apache Spark engine are going to be converted into data frames, which are in-memory tables. And all the processing is going to happen within the Spark session itself. Once the Spark session is done, these tables are eliminated. A database engine, on the other hand, works directly onto specific databases. Now, this could be an on-prem database or a cloud database, which in this case, we can take the example of an Azure SQL Server. So if you want to, go for an ELT system where all your data sets are already present in Azure SQL Server, and you'd like to ensure that all the processing and all the validation happens within the database itself, the database engine converts all these data sets that you're going to work with into temporary views, performs all the operations within the database itself using the APIs and SOAP APIs and REST APIs of the DB engine, and correspondingly saves the results into the database itself if need be. The main difference being between Spark and the database engine is how exactly data is stored and where exactly it's processed. Just to reiterate, the Spark engine does everything within a Spark session, and the Spark session could be live in an on-prem server, in a Kubernetes auto-scaling server, or Databricks system, or an EMR cluster. Whereas a database engine, once again, could be anywhere. It could be an on-prem or a cloud-based system. It could be a Snowflake system, SQL Server system, Oracle system. But the main difference here is that the data sets will be converted into in-memory tables in Spark and temporary views in the database engine. Finally, the list of services are pretty plentiful with regards to the different use cases that we support with regards to scheduling, notification, integrations with CI/CD tools and other aspects. But the place I would like to pull everyone's attention to is the three distinct ways we can interact with the product. What we are going to showcase is the web browser version of the product, implying that you can connect to different sources, define test cases, define pipelines, change parameters, and do everything using the web browser itself. We ensure that our product is both user-friendly for non-tech savvy people, and as well as has a developer mode for people who like to get into and just code the test cases as opposed to creating the test cases using drop-down menus or other helpers. So for this, we have both a web browser system for the UI, and for people who would like to code in the systems or would like to integrate the system with existing CI/CD tools or other integration systems, we have REST APIs and CLI commands. Whatever I'm going to showcase in the demo today, be it creation of a source, creation of a test case, running wizards or running pipelines, every action can be performed using CLI commands as well as REST APIs. So rest assured the corresponding way the application can be used in an automated fashion is pretty unfounded by a lot of our clients, because a lot of our clients use us in conjunction with their existing pipelines, as our product doesn't come in to disrupt it, it comes in to enhance it. So this is the architecture. Just to reiterate everything, we have an Apache Tomcat server, one of the engines, and a repo. And just to confirm, all three of these components, in most cases, are going to be installed directly onto the client's infrastructure itself. So at no point is there going to be any chance of a data leakage or data compliance being broken. Our application also is present on the Azure and AWS marketplace. This basically ensures us that there are going to be multiple vulnerability checks performed by AWS as well as Azure, as well as internal. But this basically ensures that our application can be usable for all financial clients of ours that we usually do. Additionally, as an added bonus, our application is actually being used by the US government system as well. A few of the agencies actually use us, and they have put our application through a plenty amount of valid security validations and checks. But in case anyone wants to have further understanding on how exactly the application works, how is the data being kept safe, or how is the data being compliant without any leakage, they can reach out to us for further details. We understand that particular point can be something that people would like to discuss in further. But in our case, we're not going to go through much aspect of it. I'm just going to cover one other slide and just move to the demo itself. So the next aspect that I want to cover is what exactly am I going to showcase? I'm going to showcase the application running through a browser. We're going to connect to an existing data flow server. That's something that we have as a demo. We're going to connect to a Levy system, which is an AWS system, and we're going to connect to an Apache Spark. This is what happens in the backend. Of course, as you see, each and every aspect of this can be customizable and can be defined as a user as well. So if you want to run this on Kubernetes, if you want to run this on an on-prem server, if you want to run it on Azure, you can do that. In fact, that's the example I'm going to take, that we're going to run this on Azure as well as some Databricks. So with that, let's get to the actual demo. So welcome to Data Labs. This is the DataOps suite. We have a plethora of tools within the suite, including Synthetic Data Manager, a BI validator system, data quality monitoring. But here we are going to be focusing on our migration validation solution, which primarily takes place within data flows as an ETL validator. Before everything else, the home screen actually contains the common tasks window, some dashboards to help the user understand what the past runs have been, past test cases, past pipelines, along with the user log activity with the personal as well as the teams. And finally, we have this particular container system, which is our solution for a multi-tenant isolation system. Basically, we ensure that if a particular user or an admin wants to bifurcate their projects based on the different allocations that users have based on the permissions and other data sets, they can do that right here itself. If you want to define a different environment for your dev, for your pre-prod and your prod, you can do that. Alternatively, if you want to define different environments for your projects because you have multiple folks and you cannot share those particular permissions between projects, you can do that as well using the application. Here I've just used them to segregate specific use cases, but once again, it depends on the user. So now let's move on to the other aspect, which is the sources. Of course, in this particular use case, we'll be focusing on Azure as a whole, that we're going to define a business statement as we are migrating from migrating from an on-prem SQL server to an Azure system. Here is going to be Azure Synapse, but the application is not limited to just these use cases. And in fact, the application is not limited to just JDBC systems. As you see, we have a plethora of specific connectors defined for any side of data sets that you would like to connect to. Now, this can be a typical JDBC connection, including BigQuery, Elasticsearch, Hadoop, and others. Just to illustrate what it needs to connect, it's a typical JDBC connection. So all it needs are the user credentials and the corresponding location, which here is the URL. Correspondingly, if you are working with flat files or complex files, all you have to do is define where these files are stored. Let's take an example of a basic CSV file, which is going to be stored in an ADLS system. All you have to do is define the location. Here it will be the storage account and container and the corresponding credential, which will be the access key. Moving ahead, if you're looking for something that is not really defined in the outer spheres as of now, which is not established as a full-fledged connector, while we do have things such as SAP and Salesforce as well, if there's something that we cannot cover directly, we have API connections, which a lot of our clients use to connect to their own predefined data sources. And once again, if this doesn't satisfy the corresponding client's needs, we have other ways to ensure that we connect to a specific data set in a high throughput fashion. Just to round everything up, we have BI connections as well. I'll get through these towards the end. This is just to ensure that we cover the last aspect of migration validation, which is BI validation. And of course, the other set of rules that we can apply on this as well. Finally, if all else fails, we do provide a generic connection as well that you can define for specific use cases. So let's get through the entire business statement of what we want to resolve. And let's pick up a basic example that I'll create live, hopefully, in this particular system. And what are we trying to do with this? So let me quickly delete these flows for now. Yes. So our business statement here is that we are transferring files from a SQL Server system to an Azure Synapse system. And we like to ensure that we validate the corresponding data sets. So firstly, there are multiple ways to go about this. You can, of course, do a full data compare. You can check the metadata itself, or you can check the profiles itself. Profiles here being specific aspects. So before I go to the exact aspects, I want to first check. Let's go for metadata first. I'll drag and drop metadata compare, this particular node. And then I'm going to select my systems right here. Here I pick up Azure Synapse, and then I pick up SQL Server. As soon as I click next, you'll see that the corresponding systems are auto-populated. And here I'm just going to pick up a few dimensional tables, drag and drop them, and you see the target object is automatically populated. Once again, if I do this, you see that this corresponding system says automatically populating the corresponding data sets. This is done using fuzzy logic, but if there is a pre-existing mapping document, the application can accept that as well. Now that we have done this, I'm just going to try to quickly run this particular node. What it's going to do is that it's going to pick up the metadata from both the systems of all the objects, and it's going to try to compare them to see how exactly do they match. Do they match? Are there any columns missing? Are there any data type mismatches? And here we see, okay, there are a few mismatches. Firstly, we see that there are a few columns present only in source, which is address tree in 1. There are a few columns present only in target. All right. There are a few data type mismatches as well, as we see, mainly n bar char, but there's also a few important ones with regards to int and tiny int, which can cause a lot of problems, especially if you're working with triple digit and single digit numbers in the same column. Additionally, we have a few null mismatches as well. Some key columns cannot be null in one schema while it can be in another schema. And so in this particular fashion, along with, there are no column line mismatches luckily, but in this particular fashion, we understand that there are metadata changes between the objects. So that's inherently one aspect that we need to cover that, okay? Something is a little difficult. And this is something that's inherent to the migration problem as a whole, because as you're working with different architectural systems, you're going to have inherent data type mismatches. Think of it as a way that if you're uploading a CSV file in a SQL server versus if you're uploading a CSV file as a data source through a Snowflake system, there are going to be inherent data type changes between them. And that's something that we do cover. But this is one overall system as an end user, you can identify what are the metadata changes within your different objects, within your different architectures. So that's plan A, you can do metadata change. Now let's move to the other aspect, which is you can do a profile change. Now to do the profile change, I'll actually incorporate DB flows right here. Just to illustrate what DB flows here means, just to go back to this particular deck right here. If you remember, we said that we work on Spark engine as well as database engine. DB flows are actually the flows that run within the database engine itself. Here, the example is running on a SQL server, which is an Azure SQL server. And here I've already created something very specific right here. Here I've created a very simple example. In this case, it's Snowflake versus corresponding SQL server right here, Azure SQL server it can be. And now here I've picked up the corresponding table. Now in this case, once I've picked up the table, I'm actually creating a profile of all of the specific systems. Now these include volume, null counts, average values, minimum, maximum values, maximum lengths, the amount of values which are missing, and other aspects. And correspondingly, I do the same for my Snowflake system as well. So I picked up my SQL server and my Snowflake, and I've defined a profile against them. And in this case, I'm going to compare the profiles directly. Here, I see that there's a good amount of mismatch, implying that there's a good amount of mismatch within my data set itself. I've done this from an overall perspective, so I know that there's going to be a difference in count, a difference in averages, a difference in minimum, maximum lengths, and a lot of other profiles. So this is one different way I can actually validate my data sets. But again, this is just us trying to solve the problem without actually solving the problem. The true solution to this particular problem statement is that we need to do a full data compare, and we need to isolate the data sets which are not matching between migrations. And that is where data compare comes into picture. Of course, all these particular test cases that I showcased earlier, these can be useful for specific examples in cases where you're working with really huge data sets. So if your cases you want to avoid processing a lot of data sets as a full data compare, you would like to just process profiles. Or if you're working with delta data sets, you can imagine that profiling could be a good example there. But that was just one of the ways we let our users use the product in the way they see fit. Now let's get to a basic example of a full data compare, which was our original problem statement. Let me pick up a file called dim customer, and let me pick this up from our Azure Synapse. Now all I have to do is define my data source, click next. And in this case, I'm just going to pick up dim customer because again, I prepared this as a curated example. And this is what I see. Now I click run. And basically, we are going to connect with the JDBC connection, create a temporary table, and create that in our current session, which is live at this moment. So in a few seconds, we should have the table loaded. And now I can move on to the next step, which is creating the same table, except this one we're going to pick it up from our SQL server. Let's go with dim customer and let's make this from SQL server. And we'll make sure the dependency is after metadata so that these run in parallel. There you go. And in this case, we're going to choose Microsoft SQL Server. Again, Microsoft SQL Server is just to illustrate this is an on-prem server, but it could be any other system, Snowflake or others as well. Next, and here I try to find the same table. Go dim customer, and I just run this. Now that I've had both the data sets within my system, the next thing left is just to do a comparison. But let's take a step back. We have seen that there are metadata differences inherently. There might be profiling differences inherently as well. And I don't want to have irregular profile changes or irregular metadata related problems coming up. A basic example here would be if in one system I see 10.0 and in the other system I see 10. I understand that these are the same values, and I want to ensure that the comparison is being done so that even the translated values are correct or are matched. So in this case, I'm going to pick up my data compare node. I'm going to define its dependency as both of our systems. And here I'm going to select the data sets. Once again, these are data sets. So I can do this with transform data sets as well. But in this case, we're going to go with raw files for now. And here I pick up Azure as well as SQL Server. Now, I'm going to define automatic data type conversion just to illustrate the point further. But the rest of the options can be defined if you're working with files and other data sets as well. An easy example here would be enabling trim and considering null and empty space the same is really helpful when you're working with a JDBC dataset and a raw CSV file. As you might imagine, a CSV file does not really have a concept of null in many cases. So considering them the same is very easy for the end users to define if something is being mismatched or matched. As soon as I click next, you see that the corresponding columns of dataset A and B are automatically mapped. This is done by the product inherently. I don't even have to go in and do something specific. And if there were any data type changes, as we see, those things are correspondingly changing here as well. So here, since in the properties I had defined automatic data type conversion, I do this right here as well. Now, in this case, we find that there's a few aspects which are mapped incorrectly. So I'll just relate them in the specific use case. And once again, I can sync the columns right there, and I see that the specific use case, I can just ignore this. And if there are other columns, I can add them specifically as well. Now that I've defined this, I can actually go in specifically, like for example, birth date. I can actually go in for birth date and change the formats if I have to. In this case, I don't really have to change the formats, as we see the format is same, but I can go in and specifically change the corresponding format if I have to. And the same thing applies for strings, for corresponding integers, float values, and other aspects as well. In fact, I can apply a custom function here as well if I choose to. Now let's do a basic run and see exactly where the data sets are being mismatched. So going back to our business statement, we had particular transfer of files. We have migrated files from SQL Server to Azure on cloud, and we'd like to ensure that the dataset has been migrated correctly and there are no changes in the dataset because of the corresponding migration. Metadata changes might be present, but we just want to ensure that the data is valid. So here we are running multiple types of checks on the dataset, and the results will be seen in a couple of seconds. And as we see, a few of the test cases have already failed. And once we run through the entire system, we'll see that multiple might have failed, and we see exactly why. Again, a few aspects that I have not covered are with regards to parameterizations and other aspects that I will showcase shortly. But in this case, we see that, okay, most of the test cases have run. And in fact, we're running a full outer join as well, because I've specifically asked the client application to do a full mismatch. So here we see that there's a huge mismatch within our application. So first, let's see the matched records. About 30% records have been matched correctly. This implies that 30% of the records that were transferred from SQL Server to Azure have been matched correctly. And then we see that there are a lot of mismatches. But identifying out of these, corresponding 13K records where the mismatches are is a bit difficult. So we'll use column-wise mismatches. And we see the main culprit here. If you remember, the metadata differences were across tiny int and int. And here we see that there's been a translation mishap in translation, where for one of the applications in Azure, it has converted all the ones, basically has multiplied the corresponding value by 10. And which results in this huge mismatch in data sets. I mean, they might be correct in most cases, but there's an extra addition here. In this case, something that can happen because of metadata changes. The other records are fairly true errors in actual sense. Here we see there's a .com versus .org difference, and in this case, the geography key are purely different when compared against a typical customer key. Finally, when we do an only in B and only in A, this actually implies that there are a few set of records which have not been transferred from SQL Server to Azure. This is what this particularly implies. And as if there are any records present in A, this implies that some mystery records which are not present in SQL Server are now present in Azure. Of course, that is not as likely as the records not being transferred correctly or new records being introduced into the SQL Server, as we see right here. Furthermore, if there were any duplicates within the system, we can catch them right here as well. But now let's go back to our problem statement. We have found this particular set of mismatched records. So I can't do anything with just 50 sample records of this system. I can go till 10K here as well. And I have a report as well, but I want to work on this data set. I want to fix this data set before I move it ahead. So here, I'm going to drag and drop SQL. Because all the results of our corresponding test cases are data sets, I can actually pick up this particular data set, which is the data compare difference, and work with it accordingly. So now I can either reconcile this specific system, or I can send it to the developer that, hey, this is what I see between the differences, and maybe even save that corresponding response right there as a file, or maybe back to a view as well. So this is a basic comparison data validation. We have covered metadata, we have covered profile, but this was the full data comparison, and this is just these 3 nodes right there. Additionally, on top of this, what we have done is we have picked up the difference of the corresponding file, maybe the difference, maybe the records which are present only in one data set and not the other, and then we have kind of validated them or put them to reconciliation as such. So this is a very basic example of data validation. Now let's put this business statement to the next level, which is that, okay, I have these business validations here. This is one table. I have around 500 tables I would like to validate, and I cannot go and repeatedly click the specific system right there. We understand that that is a specific use case that we have. So here, let me just put validation right here as one of the data folders. What we provide our users is the ability to create all these test cases using our wizard. So I'm just going to illustrate that particular use case here. So let's define our source as Microsoft SQL Server and define our target as the Azure Synapse. And then I'm going to import the tables from both the sources. And again, this is a screen that you've seen earlier. Let's just pick up a bunch of dimensional tables right there. Account, currency. Okay, currency is not present here. Then customer is present. Table, employee, geography, management key, and other aspects. So here we'll remove this particular one, but just to illustrate, if there's a mapping has not been found by the product automatically, you can go in and find the specific mapping here as well. And once again, if you want, you can upload a file for this mapping as well. So let's just pick up a few more right there just to illustrate the point. We have this set of tables, and again, these tables could be in the numbers of 500 or even 1000. Just to illustrate the point, we'll stick to about 810 just to showcase. And then, as we have seen earlier, the mapping is something that's being done automatically. If there were any mappings that were failing, we would have seen them as yellow. But as we see, most of the mappings are correct in the specific use case. And even the unique key has been identified correctly within both of the corresponding systems. Now that we have defined the mapping as well, the next aspect which remains is the options. Of course, this is something that we have seen earlier. Here we can define our corresponding column-wise mismatches as well. And then I can go to proceed to generate, where as soon as I click generate corresponding table, data sets, these test cases have now been generated, especially in this, in our specific folder right there. Dim product, dim geography, and so on and so forth. And you can, of course, go in and properly go in and maybe change this particular system right there, attach more data sets and more test cases to this specific use case as well, or change the corresponding source, apply some transformations, or change the, add some thresholds right here as well. So if I would like to, so in this case, if I define automatic data type conversion and if I go to mapping, the application actually will let me define thresholds for my corresponding system. Let me pick up a test example to illustrate this. So in this use case, you can define there are integers and other aspects. So let's assume yearly income. Now, an easy example here is that a lot of float values get rounded off in a different manner between the architectures. So if you want, you can define a different sort of rounding system within the two systems. But if you want to ignore this, if you want to define a threshold that, hey, if in one case I get 100.01 and in the other architecture I get 99.02, and that there's about 1% or 2% difference between them, that's okay with me. I can define that here as well. And of course, now what we've basically done is we've defined this plethora of test cases right there. And what we need to do now is define how exactly we can run all of these together. Well, for that, we have pipelines. So I've already created a specific pipeline. So let me add or create a new pipeline, define that as test. And in this specific use case, I'm going to add one specific data flow, which is our test data flow for starters. We'll just add this one at the start, define this, make a connection to this particular test case. And then in this test case itself, I want to add multiple subsequent after this. And now it's going to ask me what are the test flows I want to add in bulk. So in this case, if I want to add multiple of these, so here let's go with df_2023, because this implies our entire set of values. I pick them up, I want to run them in a sequence, but I can run them in a parallel sequence. In the upcoming release, we can also showcase how many branches and what's the length of each branch that you want. But in this case, let's just go for a basic sequence, and the corresponding test cases are added within our pipeline. You'll notice that our pipeline actually comes with email notification systems, but it's way more than that. There's a lot more scheduling systems. The application can directly invoke a Jira ticket creation in case there's a difference present within the application. The application comes with that. But before that, just to round out the entire use case of data migration validation, we have checked the metadata, we have checked the corresponding profile, and now we have done a full data compare as well. We've isolated the data sets which are not matching between the system, and we can push them further either for reporting or for reconciliation as well. So in this particular fashion, we cover data migration validation. Now, a few tidbits around this area itself. Now, I did mention that our application can actually support a lot more plugins, and that's what your application can do. So here in this case, if I want to ensure that if there's any difference between this comparison, I'm going to go in and create something called a plugin. So plugin is our answer to helping the user get any feature that they would like. So here in this case, there are lots of features that you might see. We need everything from anomaly detection, working with Excel files, creating reports, creating Jira tickets, or creating Jira tickets automatically as well. So that's the one I'm going to pick up. So in this case, what it's going to ask me is like, hey, what's the corresponding URL? What's the location you'd like? What's the summary and other aspects? Right here, you can define them. What is the data set that you'd like to define as a difference? And in this particular fashion, it's going to create a specific Jira ticket. Now, this is something that we provide, but if there's something that you would like to do yourself, the application can come in with plugins, all the ones that you define. So here, these are just a list of few plugins that the application can ship with. But once again, if you want to do anything ranging from triggering DBT jobs, working with Excel files, defining anomaly detections using forest methods, isolation forest models, or other aspects, you can do that as well. There's no limitation on what we do here because the application supports Python as well as Spark. And it allows the end developer to actually define the parameters and the datasets they want to work with. And this acts like a single repository for them. So the end user, as we just saw, only has to define the end parameters that we're working with, as we saw in plugin right here. This is just one of the illustrations on how exactly the application integrates with other tools and systems. The thing that I have not covered in this is how exactly the application integrates with Azure as well. That's something which we are going to cover in the upcoming releases, but that's just something I would like to point the attention to, because in the specific use cases I do have this plugin, but this plugin on a different aspect actually connects to publishes the results directly to Azure test plans, and we also connect to Azure pipelines as well. That's something we'll cover in the next webinar, but I did want to give it a shout out. So now that we have validated the data set as a whole, we have ensured that whatever was transferred from our on-prem system to the Azure system has been validated. We have isolated the issues. Let's move on to the next step, which is transformation validation. We want to ensure that the corresponding logic of our transformation, even if it's changing, is actually being validated. So there are two trains of thought associated with it. The first train of thought is black box testing. So here, you as the QA tester, you are not aware of the exact problem statement, which is what is the exact transformation that's happening within the corresponding layer 2 of the data set, but you are aware of the end result. You know that even after the 7 joins that are being put in this particular transformation, there should not be duplicates. You're aware that there should not be nulls on specific columns. You're aware that the particular metric should be within a certain range. You're also aware that in the specific use cases, there are the value set, the value in a particular column can only be one of 4 values. You're aware that a geographical ID should be present only with the one that maps to another file. So all this test is something that you know, even if you are not aware of the exact transformation. And if you want to validate the corresponding data set, you apply the rules there. And that is where black box testing comes in with data rules. So here the business use case is DIM customer here. This is a layer 2 file. Here we have done a lot of different specific changes to the data set. The developer has done that. And now I'm been tasked to validate this entire layer 2 data set. So how do I do this? Well, I pull in the data set from my layer 2 system, and then I apply a data rule on top of it. I've already created a bunch of rules beforehand, but the way to create this is very simple. All you have to do is define the corresponding data set. The columns are picked up automatically. And then in rules, I can either define something as simple as a duplicacy check, where if I want to define a duplicate check, all I'll do is click here and just define on which key or which column, set of columns I want duplicacy check, and I'm done. What I've done is just define a basic duplicate check on my primary key. That's all I needed to do. It's easy as 3-4 clicks. And that's something that we define as our zero code or low code system. Of course, if you want to do something more specific, we have query expression and domain rules as well. But for this example, I want to stick a little simple. We have completed our duplicacy check, our null check, and a lot of other checks actually use something called an attribute rule. The attribute rule is pretty special, and it helps a lot of our clients as it actually identifies which column we are working with and then correspondingly changes the operators in that fashion. So here I'm just trying to do a basic null check, which is applicable for any data type. So here I just define that my primary key should not be null. Okay, that's fine enough. What about middle name? Now, middle name is a number. We don't want the middle name to be a number. We just want it to be a string, and that's the test case I want to follow. But middle name could also be null. So here in this case, what I do is I define a basic filter condition. Of course, I can do this. And then I define that middle name, since it's a string, I want to ensure that it's not a number. The same thing can be done with an email address because, again, it's a string. Here I can use contains. I can also use pattern recognition or regular expression and other aspects just to identify or see how it fits in a specific rule. So here my business statement was that my email address should only contain adventureworks.com. That's what I try to achieve right there. On a different use case, birth date is a date column, and that's why we see is before, is after, and is between, and such with the specific things. And here the business rule use case is that I want my date to be before a certain date for my demographics to work. The cherry on top of this is that this particular type of this particular operator is also user defined. So if you want to create something niche which is specific to your use cases, you can define them right here as well. Let me just go to configuration once. So you can define them just as plugins. You can define something custom for your own self. You can actually define operators on your own system as well right here. And you can define for which data types these are applicable. So that was the one train of thought that we were discussing earlier. Now let's go back to the other aspect, which is, hey, I do know I do know the logic of what I'm working with right there. And now I want to ensure that I can validate that logic properly. So that's white box testing. Just to repeat the particular example, once again, we're working with the customer file, and here the corresponding business statement is that the geography key was updated. There was a new logic for the geography key, a new mapping file was introduced, and so the developer has updated this, and this is what is the target. This is something that's already been done. Now you as a QA tester, you need to replicate the logic, not copy the code, because that will transfer all the existing problems in the code as well. So you pick up the raw file and you apply your own transformation on top of this. Here I've used SQL and basically parameterize the function. But once again, I can use a DB script, I can use Python, I can use plugins, I can use any other aspect right here as well. So now I've picked up the raw file, I've applied the function, and then I've done a data compare. Now in this case, I see there's a bit of mismatch, and all the mismatches lie in geography key only, as expected, because geography key is the only column we have changed, just to know that nothing else is different. And in here, we see that there's a kind of big mismatch here. We see that the geography key for 18 and 20 between the two environments is incorrect. Now, this could mean a mapping file is mapped incorrectly, or that the logic for 18 and 20 is incorrectly done within either my function or the corresponding developer's function, and we can investigate further. So this is one of the fashions in which a lot of our clients actually use our tool to validate their logic of the ETL pipeline before they actually push the change ahead, because they would like to ensure that if you do a change on layer 1 transformation, that should not have a cascading effect on layer 3 tables as well. Because if you change something on the left side of the corresponding pipeline, it's going to have cascading effects. But if your transformation changes even a little, and there are unseen consequences, of course, unseen aspects to associated with it, you're going to have entire reports being mismatched due to a simple check, due to a simple problem, which could be as simple as a developer using floor instead of round. And if you want to make sure this is something that does not happen, you can either do this particular system, which is, replicate the logic, or the other aspect that we were showcasing, which was apply rules to ensure that the corresponding transformation is working as intended. That is transformation. And just to finish up the point on the rules aspect, we did see that we made a specific set of rules, and I can understand that a lot of these rules, the black box testing is what a lot of folks will be more geared towards, given that it does not require anyone to replicate logics right there. So just a quick pointer on rules is that all these rules as we see right here can be easily parameterized using the application right there. And all of the rules are exportable and importable as well. So you can define very custom set of rules. And as we saw the wizard for the corresponding data migration, there's also a wizard for data quality rules as well. So you can define rules once and then apply them to say 50, 60 tables or 50, 60 columns all at once from one specific system. And everything, as we just saw, the results of this also actually showcase what are the corresponding records which are incorrect. Now, this can either be downloaded, exported as a CSV, associated in a specific report, or created as a subsequent system. So that is transformation validation. Just to complete this aspect and add a few more on top of this. If you're working with any sort of transformation within your system, you'll see that there are a lot of specific use cases that you would like to cover. So in this case, let's go with SQL right there. And if in this case, if I want to define a query builder, I can use query builder, but I also come in with a AI assistant right there. This is a GPT connection, but in the upcoming releases, we are gearing this much more to have auto completion and other associated use cases as well. To the point that if you just define the metadata and we can actually send the metadata directly ahead, the corresponding AI can return us the exact set of queries and rules that you might want to define for your specific system, along with, of course, code completion, as we see with the copilots on other natures. So another thing, the side aspect of this is we are also developing a personal LLM for us as well. This is an internal LLM, which is going to be specific in the code. The main reason for that is some users might not be comfortable sending any kind of data to OpenAI. And for that, we're also creating a personalized LLM. And this is just a preview of the initial feature. There's a lot more upcoming within the system. Now that we've just to reiterate everything what we've done so far, we have defined the corresponding data migration validation. We have done ETL validation as well. Let's finish this up in a specific system and let's talk about BI validation. So from an overall perspective, what has happened? Well, we have migrated from one source to the other, and now we have also migrated our BI system. Now this could be a migration of BI tools. This could be you just picking up Power BI from yours, which is connected to your SQL server, and connecting it directly to your Azure system. It could be that, or it could also be that you have different environments for Power BI itself. One is a on-prem deployment, another is a cloud deployment. So you have this different set of use cases that you want. But at the end of the day, the reports is what everything is gearing towards. The rightmost system is either analytics or it's reports. And you'd like to ensure that the reports that you're defining are valid. So this is where the suite actually kind of ends towards the right-hand side, which is where we perform BI validation. An easy use case here is that you can define, this is a Power BI node. And in this case, you can define the two connections. For this use case, it's the same. And of course, I can define a lot more things on terms of the type of filters if I want to compare, if I want to define if the notification should be excluded or not. And in this case, I'm going to go in, and this is directly going to connect to your Power BI system. It's not going to take an image. It's actually going to connect directly to your Power BI. In fact, you can actually see all the workspaces that I can associate with a particular user and define specific filters. Do that for my report A and report B. Here, the use case is that report A and report B are the same reports, except they're in different environments. So I'd like to do a validation check, and that's why we're calling it upgrade test plan. And so I've pulled in the reports from both sides. And here, I've already run this before. So here it shows me that the corresponding test case has failed. And with a greater look, I see, okay, this is definitely incorrect with regards to name. And even the figures are actually slightly incorrect. We see there is a bit of difference between the values that we see for Europe as well as the Asia Pacific percentages. If I want to go dig deeper, and if I'm working with, say, other visual elements, I can actually point out and highlight exactly where we see the differences. So here we see that the sum of sales, this particular text was center aligned versus left aligned. And a lot of the aspects can also be found out within the application. Of course, this rabbit hole goes much deeper for our system because we can actually pull these specific data sets and connect them to pull these specific reports, the data set that you see this dashboard, and connect it to a data set as well and validate that corresponding system. But we'll be sticking to the migration validation toolset that we have. So with that, we're almost wrapping up with the system. Before I wrap up and you give a refresher on what we've discussed, can we have some questions?
Yes, Shubhanshu. We have one question from the attendee. Can we apply transformation rules on both source and target DB?
Yes, that is an excellent question. In fact, I would like to just illustrate that if that's a specific question. So here, let me go back to the test case that we were working with. Apologies for that. Let's go to the migration container that I was working. So here I see test right there. Now here I was working with these two systems. So let me just delete this right there. And now I'm just going to define SQL. This is going to be SQL. Let's call it SQL 1. It's for the SQL server. Drag and drop right here. Of course, I can perform a lot more validations here as well, but I can perform any sort of system. Let me rerun this entire session once again. And so I can perform this particular SQL right there, then perform maybe a Python code on the other system, and then compare those two data sets as well. So we can perform n number of transformation data rules to both the selected DBs files, BI systems, anything that you think of. There's no limitation that the product gives the corresponding user. You can do anything that you want to do within the application, and we allow the user to define that specifically. Are there any more questions that you would like to cover?
Nothing as of now. You can continue.
So the plan on this particular point, just to close out, I just wanted to give out a brief overview on just to refresh on what we have covered in this particular webinar. Well, firstly, we have started with the business statement that we were transferring. We're migrating from a particular location. In this example, it was Azure Synapse to Azure Synapse from any system. In this example, it was a SQL Server system, but it could be Snowflake, it could be an on-prem server, it could be Oracle, it could be anything. The application has a plethora of data sources that it can inherently connect to. The next thing that we try to understand is how exactly can we validate data. We have validated data with regards to the metadata, we have validated them with regards to the profiling, and we have done a full data compare itself, as we just saw. We can do this after transformations as well, and we can apply n number of transformations before any kind of validation rule set or validation check. After this, what we have done is we have tried to run this particular migration across multiple tables. We have created test cases for about 8 to 10 tables within few clicks, and the same can be done for 500 tables as well, since the application is intelligent enough to understand the mapping and corresponding data type mapping changes that are needed. Then correspondingly, we've created a pipeline that runs all these test cases and showcase that these test cases can be inherently linked with Azure DevOps and Azure pipelines as well. The focus of this Azure DevOps and pipelines will be done in a separate webinar, because the list of features that we support is too long for this particular webinar. But we connect to that, so the results can be viewed in both the locations, either in ours or in theirs. All the test cases create specific reports, and each of the reports are something that you can view right here, or you can connect with your own system to view. And these reports are something that are also shared with corresponding users using the linked channels. Now, this could be your Jenkins system. This could be other aspects here as well. So just to illustrate, this is one of the reports that you might see, which has the nodes and other aspects. So finally, we then went into the ETL transformation logic, where we actually wanted to validate transformation logic. We saw the two distinct ways you can validate them, either by rules, or you can validate them by replicating the logic and comparing the transform data sets. So that's the two distinct methods we can do that. And of course, with the upcoming Copilot integration that we are planning, this will be much more easier, because the user just has to provide the right context to the corresponding AI assistant, and the AI assistant will either do code completion or will define rules and help the QA tester define the set of rules that you might want to define right there. Finally, we looked at BI validation, where we actually compared a couple of BI reports from distinct locations and saw what was the exact differences, be it in the data sets, be it in the positioning, be it in the color legends, or be it in the set of filters that both of them were working against. So this is a data migration. So this is our migration validation system. Of course, in this, for the interest of time, we have skipped a lot of specific features, such as working with complex files, defining integrations, CI/CD integrations, a lot of scheduling and integration aspects with regards to test plans other than Azure as well. But again, this is just the tip of the iceberg, and we hope that we have garnered enough interest or help folks understand how the product will work across the multiple dimensions.
Great. We have one question, Shubhanshu, from the audience. Is there any limit on volume to be tested on this tool?
That's an excellent question. So the application architecture, if I can just quickly get back to that, since the application in many cases is going to be run on Spark Engine, and Spark Engine is horizontally scalable. So there is no set limit on the particular application. The application has been run with terabytes of data and individual files of terabytes being compared directly against the other. Of course, the main cutback here is with regards to the hardware on which you run it. But since the application supports Kubernetes, a lot of our clients actually use the Kubernetes auto-scaling feature to validate really huge data sets at very efficient cost. So yes, there is no limit as such, and our application does regular stress testing to ensure that we support terabytes of data sets.
Great, thank you for that. So Dave, do you want to address any of the common challenges our customers face, or anything that they specifically point out that this tool has been addressing the issue in a very good manner or a best manner?
Yeah, well, I think we're running out of time, but yeah, certainly our customers that are using our technology for migrating to the cloud are finding that what they can do is test all the data. and it can reduce their manual testing by 60-70%, helps them keep on track with their migration efforts. And they feel like once the migration has been done, they can trust the data that's been migrated because it's been thoroughly tested. That, again, is one of the bigger pitfalls in migrating to the cloud, is the fact that, the complexity of all the data that needs to be moved, the complexity of the data itself, it just has some potential of a problem of causing problems. And if you don't find it early, it costs a lot more to fix once it gets into the cloud. So I would like to say thank you for those that attended. We appreciate your interest. And we also offer custom demonstrations for you in your environment. Happy to develop custom demos for you. And just let us know how you'd like to follow up. And we appreciate your time today.
Thank you, Dave. Thank you, Shubhanshu, for it. And thanks everyone for joining today. Thanks again. Bye.
Thank you.